Good evening, class 9, unit sound part 2, standard 9. But it is also related to class 8. Question number 1. On what factors does sound speed depend? Sound speed कुन factor मा depend हुन्छ? केले चाहिँ sound speed लाई असर पार्छन्? The answer is as follows. Sound speed V depends upon the following four factors. But one thing, sound speed does not depend on pressure. Number one is wind direction. See, same direction or opposite direction. Same direction भएमा बढी हुन्छ sound speed र opposite भएमा कम हुन्छ. How to write down in language? Wind speed, wind direction, sound speed V increases or is more in the same direction as the wind and less in the opposite directions. That means if the sound and wind move in the same direction, the speed of sound is more. If they move in the opposite direction, the sound speed is less. Sound र wind same direction मा भएमा स्पिड बढी हुन्छ किन विन्डले पनि के हेल्प गरेको हुन्छ अपोजिट भएमा चाहिँ त्यसलाई रिटार्ड गरिदिन्छ मोसनलाई स्पिडलाई घटाइदिन्छ. And number 2, sound speed. Another absolute temperature. T0. Absolute temperature बढी भएमा स्पिड बढी डाइरेक्टली प्रोपोर्सनल हुन्छ. Sound speed V is directly proportional to the square root of the absolute temperature T0. Mathematically, we write this. If temperature increases 16 times, speed increases 4 times only. And if temperature decreases 4 times, speed decreases 2 times only. Sound speed is directly proportional to the square root of the absolute temperature. Wind direction and absolute temperature. Question number 1. 2 factors, wind direction and absolute temperature. Now, humidity and density. Humidity, amount of water vapor present in air. हावामा पानीको मात्रा. Humidity is sound speed V is directly proportional to the humidity. Yes, mathematically we write as this. More humidity, more speed. Less humidity, less speed. It means if air contains more amount of water vapor, the speed is more. For example, at night speed is more, in the daytime speed is less. Another is density, main density D, for solid and liquid directly, and for gas inversely. Or you can write in one language, sound speed V is directly proportional to the square root of the density of a density D of a solid or a liquid. Sound speed V is directly proportional to the square root of the density D of a solid or liquid, and inversely proportional to the square root of a gas. How to write down mathematically? D for solid and liquid, and gas for any gas. See, for solid and liquid, sound speed is directly proportional to the square root of the density of solid or liquid. But for gas, sound speed is inversely proportional to the square root of the density. That means for solid and liquid, more density, more speed. Less density, less speed, square root times. For a gas, more density, less speed, less density, more speed. ग्यास को लागि इन्भर्सली सोलिड र लिक्विड को लागि डाइरेक्टली प्रोपोर्शनल हुन्छ. सी व्हाट आर द फोर फ्याक्टर्स? विन्ड डिरेक्सन, सेम डिरेक्सन मोर, अपोजिट डिरेक्सन लेस. हेर्नु त, विन्ड डिरेक्सन एउटा, अर्को छ एब्सोल्युट टेम्परेचर डाइरेक्टली, ह्युमिडिटी डाइरेक्टली, डेन्सिटी फर सोलिड एन्ड लिक्विड डाइरेक्टली प्रोपोर्शनल, बट फर ग्यास इन्भर्सली proportional to the square root of the density. Question number 1 finished. Wind direction, absolute temperature, humidity and density are the four factors. One notice, sound speed does not depend upon pressure. Pressure ma hudaina. Pressure. When the pressure increases or decreases, sound speed does not increase or decrease. Does not depend upon pressure. Question number 2 is distinguish between echo प्रतिध्वनि and reverberation गुंजायमान in Nepali. Main differences between echo and reverberation as you learned in class 8. Number 1, echo is the sound reflected from a distance of about 16.5 meter or more in 0.1 second or more. From a distance of about 16.5 meter or more and time taken is 0.1 second or more. Echo is hot reflected sound, but reverberation, it is the continued elongation or prolongation of echo mixed with the original sound. From a distance of about 14.5 meter or less in 0.1 second or less. Time taken is 0.1 second or less. The distance between the source of sound and reflector should be about 14.5 meters or less. That is reverberation. Prolongation, it is odd once, it is odd several times. Example, sound from a small room, lecture hall, lecture or cinema hall, etc. Here, echo, sound from a hill, mountain, cave or den or forest. About 16.5 meter or more, time taken 0.1 second or more. Or only once. Here, distance is 14.5 meter or less, time taken is 0.1 second or less. It is mixed. Reflected sound is mixed with the original sound. That is reverberation. It is heard many times. Question number 2A. To be longitudinal wave and transverse wave. Main differences between longitudinal wave and transverse wave are as follows. First of all, let me draw the diagram so it becomes easier to you. Compression, rarefaction, compression, rarefaction, 2 years. Here, crest drop, crest and drop. So it becomes easier to understand. Longitudinal wave, transverse wave. What is one difference? Main difference, so see, the wave travels in the parallel or same direction. Which the wave travels in the parallel direction or in the same direction as the particles of the medium. जुन मिडियमबाट ट्राभल भइरहेको छ सोलिड लिक्विड ग्यास, त्यसको पार्टिकल जता जान्छ साउन्ड वेभ त्यतै जान्छ भने लongitudinal वेभ भयो. The longitudinal wave travels in the same direction as the particles of the medium, but here the wave travels in the perpendicular direction. In the perpendicular direction as the particles of the medium. To understand easily, see, suppose this is the wave, they are the particles. If particles move in this way, the wave moves in this way. But if the particles move, or particles and wave, the particles and wave make an angle of 90 degree. 90 degree ma. But here same direction or in the parallel direction. It has generally low speed and low energy. Generally low energy and low speed. It travels in the forms of compressions and rare fractions. Example, sound wave. Waves produced in a slinky spring or helical spring. Helical spring मा wave produce हुन्छ, त्यो चाहिँ compression र rare fraction. Compression region of high density, rare fraction region of low density. Longitudinal wave travels in the same direction as the particles of the medium. It has low energy, low speed, and it travels in the forms of compressions and rarefactions. Example, sound wave or acoustic wave. Waves produced in a slinky spring or helical spring. Here it has generally high speed and high energy, more energy. It travels in the forms of crests or troughs. Crests or troughs. Example, light wave. Light wave, electromagnetic wave, X-ray, beta ray, gamma ray, etc., alpha ray. Another, waves produced on water. Waves produced on water. When a stone is dropped, पानीमा ढुङ्गा राख्दाखेरि wave produce हुन्छ, त्यो चाहिँ transverse wave हो. So light wave पनि एउटा example हो. They are the main differences between longitudinal wave and transverse wave. Another, light and sound. B, light and sound. B, longitudinal and transverse. C, light and sound wave. It is better to understand. C number is light wave and sound wave. Main differences. Can you guess some main differences between light wave and sound wave? Yes, of course. Light, form of energy, it is also a form of energy. But what is the difference? You write down the difference only. It is a transverse electromagnetic wave. It is a transverse electromagnetic wave It is a longitudinal mechanical wave. Just by the name, by transverse, it means it travels in the forms of crests and troughs. Longitudinal, it travels in the forms of compressions and rarefactions, and it needs a medium. You know that it needs no medium. It needs no medium means it can travel even through vacuum. It has high speed and high energy. One, it travels in the forms of, say, light, crests and troughs. It affects what? Eyes, like aha. It affects eyes. It is a longitudinal mechanical wave. It needs a material medium. It needs a material medium to travel or propagate. It has low speed and low energy. Low speed, low energy. It affects ears. It travels in the forms of sound wave. Compressions and rarefactions. See, light wave, transverse, write down characteristics, nature of transverse wave, sound wave, write down the nature of longitudinal wave. Example not necessary, light wave, light itself, sound wave. Question number 2, ABC finished. Question number 3 is related to some definitions. Question number 3, define the following terms. Compressions. It is the region of high density and sound speed is less in case of a longitudinal wave. In case of a longitudinal wave, region of high density. B, rarefactions. In case of a longitudinal wave, what is rarefaction? Rarefaction is the region of, see, sound speed is less, high density, less speed. It is the region of low density but high speed. Already told, sound speed is inversely proportional to the square root of the density of the gas. Gas को density high छ, sound speed low. Density low, speed high. C number, amplitude. This is the in case of or transverse wave. This is the amplitude A, maximum displacement of a wave. In case of a transverse wave, in case of a transverse wave, amplitude A is the maximum displacement of a wave from the mean position of rest. Mean position of mean position of upward or downward motion. What is the maximum displacement? कति displacement माथि गएको छ तल गएको छ. It is the amplitude, maximum displacement of the wave upward or downward from the mean position of rest. It occurs in the case of transverse wave. Transverse wave को लागि amplitude को अब C number amplitude, time period, frequency C number amplitude C D, our D number is crest and trough. Crest and trough. Crest is the highest point of a transverse wave. It is denoted by C. But here sometimes C for speed of light, but in this case C is crest. E, trough. यदि माथि जान्छ trough. Trough is the highest, lowest point of a transverse wave. It is denoted by T. T for trough, trough T, down, तलतिर आएको. C for crest. Another wavelength, amplitude, compression, rarefaction, wavelength. Now, before this, time period and frequency. Time period भन्नाले एउटा वेभ बनाउन लाग्ने समयलाई हामी टाइम पिरियड भन्छौँ. It is the time taken for a vibrating body to make one complete vibration or revolution. It is denoted by T. It is denoted by capital T. Formula is 1 by F. In 1 second it makes F and T time 1 by F. E time period E F G. Can you say what is left? Frequency. Yes. Avriti. Frequency. In option math, we always use frequency in mean mode median range. Mean mode median range गर्दा यो क्वार्टर डेभिएसन निकाल्दा हामी फ्रिक्वेन्सी भन्ने वर्ड हामी युज गर्छौं. Total number of items. Frequency. But here, how to understand frequency? Frequency, number of complete vibrations made by a vibrating body in 1 second. 1 second मा कति पल्ट यो घुम्छ, कति भाइब्रेसन बनाउँछ, त्यो नम्बर नै फ्रिक्वेन्सी हो. The total number of complete vibrations made by a body per second is called its frequency. Its SI unit is hertz. HRTZ hertz. And other units are kilohertz and megahertz. Formula we can find V by lambda, or frequency equal speed of sound upon wavelength. What is frequency? Number of complete vibrations made by a body in 1 second. Its SI unit is hertz. 1 second में कतिपल्ट घुम्छ, कति भाइब्रेसन बनाउँछ, कम्प्लिट भाइब्रेसन बनाउँछ, that number. SI unit hertz HZ. Other multiples of hertz are kilohertz and megahertz. G, H number. H. Possibly the last for today. H number, wavelength. तरंग लंबाई. See. Crest, trough. Crest, trough. Crest and trough. Crest to crest, trough to trough. Not only this, from sometimes here. ठ्याक्कै कम्प्लिट भाइब्रेसन बढेको हुनुपर्छ, यहाँदेखि यहाँसम्म कम्प्लिट भाइब्रेसन, फ्रम हियर टु हियर, द्याट इज अल्सो wavelength. In case of transverse wave, wavelength is the distance between two successive crests or two successive troughs. Distance from one crest to next crest, or the distance between two consecutive troughs, or distance between two consecutive crests. एउटा क्रेस्टबाट अर्को नियरेस्ट क्रेस्टको डिस्टेन्स, वान ट्रपदेखि अर्को ट्रपसम्मको नियरेस्ट डिस्टेन्स. वेभलेन्थ, it is the distance between two successive crests or troughs. In case of a transverse wave, within the bracket transverse wave को लागि भन्न खोजेको, or successive crests or troughs or compressions or rarefactions bracket in case of a longitudinal wave. Longitudinal wave को लागि distance between two compressions or two rarefactions. In case of a transverse wave, distance between two crests, two successive crests or two successive troughs. See, compression, rarefaction, compression, rarefaction, compression to compression, lambda, rarefaction to rarefaction, lambda. It means wavelength is denoted by lambda. Its SI unit is meter. Formula lambda equal V by F. Wavelength equal velocity by frequency. Formula. So it is the distance between two successive crests or troughs or compressions or rarefactions. Compressions and rarefactions in case of longitudinal wave, crest and troughs in case of transverse wave.